You might not have noticed, but road signs have undergone a subtle change in recent years thanks to advances in technology. Today's signs are more reflective than ever. You can actually read them in the dead of night, even when the only source of illumination is your car's headlights. The earliest road signs were crude, a stick in the ground or a heap of stones to mark a route. In the Roman Empire, stone posts were erected along roadsides at regular intervals, indicating the distance to Rome. Centuries later, stone marker systems gave way to wooden cross signs pointing in several directions at once. The international system of road signs we know today came out of the first International Road Congress held in 1908. The process of manufacturing a road sign starts with a computer. The government strictly regulates the specifics of the design and requires a certain degree of reflectivity. The computer's specialized software guides a machine to cut the design on a sheet of film. Once the design is cut, workers carefully peel off and discard the pieces. What's left is a film stencil of the sign, in this case, a French stop sign. They inspect it for defects, then prepare a screen of polyester fabric that they'll later use to print the sign. They start by coating it with a thin layer of light-sensitive emulsion. Once the emulsion's dry, they adhere the film stencil, using vacuum pressure to flatten it and get rid of any creases or air bubbles. Then they expose the screen to an intense 6,000 watt light for 7 minutes. This activates the emulsion on the lettering and area outside the octagon, what's not shielded from the light by the film stencil. This exposed emulsion hardens, plugging the minute holes between the screen's fibers. After rinsing, you see the result. Elsewhere in the factory, meanwhile, workers cut the aluminum panels on which the signs will be printed. Using a punch press, they round out the edges and make holes for the bolts that'll later attach the sign to the post. They stamp on the company name and the year of manufacture for warranty purposes. They immerse the panels in a chemical bath to remove grease and other residues. Then they rinse off the panels and dip them in an acid solution that seals the metal to make it better withstand harsh weather. Next, they laminate the aluminum panels with a film containing minuscule glass particles. This film will make the sign reflect in the dark when light hits it. Then they cut the panel to the final shape. Now they can finally print the sign. The process they use is called silk screening, although the fabric screen, as you saw earlier, isn't actually silk, it's polyester. The machine forces the ink down through the screen onto the panel. The ink penetrates through the open fiber holes of the octagon, printing the red background of the stop sign. But it can't penetrate through the blocked fiber holes of the lettering and area outside the octagon, so those remain white. The freshly printed signs pass through a dryer at 66 degrees Celsius for 5 minutes. To produce street signs, workers first laminate aluminum panels with reflective film for the background color. Then either silk screen the street name or apply self-adhesive reflective lettering. But it's back to the silk screening process for printing multicolored signs. Workers print them one color at a time with a drying cycle between colors. All the film stencils are carefully stored for future use. The printed signs go into an oven for a final curing at 176 degrees Celsius, an hour for a one-color sign, a half hour per color for a multicolored sign. The ink is transparent enough not to block the reflective film underneath. Therefore, the entire sign, not just the lettering, is highly reflective. That maximizes the sign's visibility, thereby minimizing the excuses drivers can come up with for not heeding it.